A question that I get asked a lot is, when I'm dealing with a capacitor or an inductor, which equation do I use when? The most commonly confused equations for the capacitor are those for the capacitor's voltage. If we're dealing with a pure capacitor that has a current through it, we might say that the voltage as a function of time is given by this equation. This is the voltage across the capacitor as a current flows through it from some time t0 up to t. In theory, this equation will work no matter what you have. However, you need the current. There are some cases in which either you don't have it or it's simpler to ignore it. So although this is the most general, when you're dealing with an RC circuit, we have an equation that actually follows into this one, but is a little bit simpler to use. We know that Vc of t is given as Vc of infinity, either if it's charging or discharging, we have to be aware of that, plus Vc of t0 minus Vc of infinity, and all of that is multiplied by e to the negative t minus t0, making sure the brackets are in the right place, over, and I'm going to use the symbol tau again. So, this equation is what we get. It is a general equation, but only for RC circuits. It handles these two cases, and that's why it's general. Charging and also discharging. It handles both. Typically, in discharging, Vc of infinity is 0. Although that may not be entirely the case depending on how the circuit is set up. In charging, we need to think about both of them. The key is that although this equation will work no matter what, we would need the current. So if we were to redo our entire analysis of an RC circuit, we could end up using this equation provided we knew those currents. On the other hand, if we don't know them, or if we do know we have an RC circuit, we can skip directly to this more general equation. Sometimes, the equation is given in an even more general form, as x of t. And you'll see there's a familiarity to it. It's going to look almost exactly the same as what I wrote for the voltage. In this case, this will work both for inductors and capacitors, and for charging and discharging. There are two things that we need to make sure that we take into account. For inductors, X is current. For capacitors, X is voltage. Similarly, for inductors, tau is L over R. And for capacitors, tau is RC. So before you start using this equation, make 100% sure that you know which kind of circuit you're using. Is it an RL or an RC? And then, once you know which one it is, make the substitution that X is either the current or the voltage right away, so you don't mix it up. The next thing is, once you've again determined which of those two types of equations you're dealing with, immediately figure out what tau is and put it into your equation. At that point, carry on and find out what is your infinity and your initial to finish up the equation.